real exam questions. This is question 22 and goes about slabs in general. A rectangular slab is loaded with a uniform distributed load. The figures on the right-hand side show the isolines of the bending moments. Based on these figures, determine the nature of the support of the edges of the slab. Second part of the question is, what is a torsional bending moment? And the third part is the shear force at the end of a supported slab and loaded with a distributed load is not always equal to the shear force at that location, as with a beam. How is this possible? So we first have a look at those three figures. My, it's the bending moment in this direction. So it's the vector of the bending moment is pointing in the y direction, the green one there. First, what we see is that let's take side A, and you see that the bending moment is there 0. Also, from the other direction, the bending moment is as good as 0. And we see the torsional bending moments, that there is a torsional bending moment with this shape in the corners. So this means that the condition of this, the conditions of the support of this side is equal to the condition of support on this side. That's why you have a thing like that. So here we can conclude that the side A is simply supported. Now we go to side B and D, you will see it's the same. And like A, it's exactly the same. And we see also that on this side, there is no, or the torsional bending moment is less than in the other corner. So, but for the rest, the bending moment is there, mx or my is 0. So HB and HD is also simply supported. Then we come to HC. You see for HC, you should conclude from this picture that it's also simply supported. But for the bending moments in the y direction, you see that the biggest bending moment is in the middle. So it means that this cannot be supported. When you look again at the torsional bending moments, if this line C was supported, then you should have the same picture from the torsional bending moments as on this side, because those two are simply supported. So we can now safely conclude that C is free. It's a free and not supported. This way you can calculate your model to see if it's behaving like you wished in the beginning. What is a torsional bending moment? Well, the torsional bending moment refers to the moment of force that causes a deformation due to rotation, usually about a longitudinal axis. In fact, it's just the bending moment parallel to the cross section. The shear force at the edge of a supported slab is loaded with a distributed load is not always equal to the shear force at that location. So how is this possible? The shear force for a slab, if you take the general equations, the equation of Lagrange, Kirchhoff-Lagrange, for take the general formulation, then you will see that the shear force is equal to the shear force in x direction plus the first derivative of the torsional bending moments in the y direction. Same applies for the y direction. And you see clearly that this is different because for beams, the shear force is equal to the first derivative of the bending moment. So this is Vx, small Vx, is the same. So there's something added to it. And that added is only depending on the torsional bending moments. So the increase or decrease of the torsional bending moment contributes to the total shear force, which is this term. So it means that at the support, Qx or V, is then the reaction force at the support. So the reaction support is not just the shear force, but also the variation of the torsional bending moment.